So today we're going to look at where do these rules come from, these 45, 45, 90, and 30, 60, 90 rules. This is a good way, if you're not a great memorizer, you can use what we're about to do to re-remember the formulas once you come in to take your test. So for 45, 45, 90, we're going to start with a square where we're going to draw the diagonal of that square. And because this is a square, what it's going to do is it's going to split these into two congruent angles, 45 and 45, on both sides of that. And then we're going to think about just a generic number. We're going to choose any number that we want. Maybe we'll choose 5, 6, whatever you prefer. So because this is a square, if this side is 5, so are all of these other sides, right? They're all 5. So if I look closely at this triangle, I now have that the two legs are congruent, and I don't know the length of the hypotenuse. But to figure it out, I can use Pythagorean theorem, and I end up with c squared equals 50, which means I need to take the square root of 50 to get my hypotenuse. So when I do that, the square root of 50, I'm going to rewrite that as 25 times 2. I'm going to break that into two square roots. And I know the square root of 25 is 5, so I end up with 5 square roots of 2. And what that shows me is that whatever the legs are end up being the number in front of the square root of 2 for the hypotenuse. So then I can turn that into the formula. The hypotenuse will always equal whatever the leg is times the square root of 2. And that's just kind of a nice reminder of where that's coming from. If you were in class the day we did this activity, hopefully you remember that experience. If not, you can use this technique to help jog your memory of the rules for 45, 45, 90. For 30, 60, 90, we're going to start with an equilateral triangle. So when that happens, we know all of our angles are 60 degrees. And I'm going to draw an altitude, or the height, straight down from that figure. So what that's going to do is it's going to split this into two equal angles. And the reason it does that is because if these two sides are equal, that vertical height will always split the vertex angle. So once we have that, since this started as an equilateral, again, we can pick any arbitrary number we want to represent those three equal sides. In this case, it's going to be easier for you if you pick an even number because it's going to come out a little bit nicer. But what that altitude or that height is going to do to that 6 is split it into two equal pieces. And then already, just by looking at this triangle right here, this 30, 60, 90, I can already tell that the hypotenuse is double the shorter leg. And I know that's a little bit hard to see there at the end, but the hypotenuse is double the shorter leg, is what that says. So what I need to find is this longer leg, or L. That's a cursive L, just in case you've never seen that before. So I'm going to say L squared plus 3 squared should equal 6 squared. So L squared plus 9 equals 36. I can subtract 9, and I end up with L squared equals 27. And then from here, I'm going to take the square root of 27. So take the square root of both sides. I know that 9 goes into 27 3 times. So I'm going to rewrite that as the square root of 9 and the square root of 3, which means my length is 3 square roots of 3. And we'll notice that that 3 comes from right here. So my longer leg is always my shorter times the square root of 3. Again, this is just a summary of where those rules are coming from, and this is a way to help jog your memory if you forget the formulas on the test. Have a great day.